Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back to finish wiring up these output tubes, and once we get these wired up and get the current running through them, we'll be able to pull this thing up on the Variac and see what our B+ voltage is really going to be, because until we have a load on the power supply, we really can't tell what things are going to be like. So hopefully we've got the right transformer and other components in our power supply to end up with the voltages we need to see to make this amp sing. So let's get to finish wiring this thing up. So we got our wires bent up for our cathode resistor, and it's gonna sit like this, go in that bottom hole and up in this top one. And I'm actually kind of temporary soldering this in, because when the thermal pads come, I'm gonna have to unsolder this and then put the pads underneath and then solder it back into place and push it down up against the chassis after I clear off some powder coating. But right now I want to get it soldered in so we can check our voltages. I wish the pads were here, but they're not going to be here till the first of next week, and I don't want to wait that long. I want to try to get this video out this weekend. So we got that guy. The other two pieces we need, this is the grid leak resistor that's going to go from the grid over to ground. And so let's go ahead and I'm going to pull this out of the way for a second and get this little resistor. I want to stand it off a little bit, so let's wrap it around like that. And while I'm trying to be fairly neat on this amplifier, I'm not quite going to the extremes that I did on my 47 amp, but it's still going to look nice. That. So we have our grid stopper reference to ground, so that when we get the voltage on the cathode, it will be a negative potential on the grid, which will keep the tube in check as we power it up. So the next thing we need to do is we're going to put this cathode resistor in place. And I'm putting in the bottom hole. Get in here and solder this lower terminal and get that connected. Like that. Then the last piece we have is this bypass cap. Crimp this down, so hold it in place while we solder it. And then I think I'm going to stand the amplifier up on its end to solder this other lead on. So let me do that real quick and I'll show you what that looks like. And there we go. We got the bypass cap soldered across here. We've got the cathode resistor soldered in there, and then we got our grid leak resistor going from the grid over to ground. Let me zoom in here and give you a little better angle here. You can see the cap that's going from this terminal to the center ground terminal, and then you can see the grid leak resistor is going from here over to the center one. And then once we get our capacitor hooked up to this one, we'll finish soldering up that lug. But those are connected electrically enough to power this thing up. So now the next thing we need to do is repeat what we did here, over here. Get all this stuff connected to both tubes. Then we can put our tubes in, hook this thing up on the Variac, and see what our B+ with a load on it's going to be. And also what kind of voltage drop we have off of this resistor to make sure that our tubes are running at the current rating that we want to see them running at. So I'm going to go ahead and do this part off camera because it's just a repeat of this, and then come back and we'll power this thing up. Be back in a few. Okay, well, I powered this thing up earlier on the Variac and got a little disturbing voltages, and I'm going to show you what this thing does plugged into the line using an isolation transformer, but otherwise just have straight line voltage going into the amp. Don't think it's going to melt anything, but the voltages are higher than I would like to see. And I was a little concerned that this power transformer I was using, I would end up with too high a voltage, and that may be the case. But I'm going to try some tricks and see if I can make this thing work for me. It was extremely too high with the 5U4C, and so I dropped the 5R4 GYB tube in it, which has a lot higher voltage drop as far as the rectifier, and I got it down to, well, I'll show you what we got. So we're going to power this thing up. As you can see, this isn't a slow warm-up rectifier, and we had 460 volts until the tubes start drawing current, and once they do, we're down to 350, and it's probably going to go a little lower. Let's let it run a minute and just see what it stabilizes at. Okay, looks like 349, or right at 350 volts, and that's on the B+. So next, and I do have my hand behind my back, going in here with one hand, and this is on the plate. We got 341, which to me isn't ridiculously high. I mean, it's a little higher than what the tube's rated at, but that's not really my main concern. Let's come over here to the cathode. So let's read it here. We got 12 volts on the cathode, and that drop across a 270 ohm resistor is running the tube at 100% of its rated dissipation, which is just too hot. I don't think the tube's going to last long running it that hot. These are Gold Lion EL84s that are rated at 14 watts. Some of them are only rated at 12. That's running at 100%, which is just too hot to be running a tube. I like running tubes hot, but that's just a little too much for me. And the other channel is the same thing. We got 12 volts. So we need to address that. I'm not as concerned about the voltage, because if you take the 340 and then you subtract this 12 volts, we're running at 328 across the tube, which, yeah, it's a little bit over the maximum volt of the tube, but in my experience, that's not the deal killer. Running too much current through the tube is what kills them. Now, the other thing, and I mentioned this earlier, that I might be a concern was, what kind of voltage are we seeing on the screen? So I'm going to come in here with my probe. We got 346 on the screen, which is 5 volts higher than the plate. Same thing on that tube. And I don't like seeing the screen higher than the plate. Sometime I'll go into explaining how the screen versus the plate works, and how a beam power tube works and what the screen's doing. But I want to get the screen voltage lower. I'm going to go and turn the amp off. I feel like that might be part of the problem. So the first thing I want to do is I'm going to come in here and increase the value of this screen resistor from 100 ohms. I'm going to probably try a 1.2K and see what the screen voltage is. And what I want to see is it just under the plate. 2 or 3 volts is, I feel like, ideal, down to maybe 5 volts under the plate. And then I want to do that and then recheck what the cathode voltage is after adjusting the screen voltage. And if the cathode voltage is still high, I'm going to change the cathode resistor to a 300 ohm and then go up to a 330 ohm if I need to, and try to get the tube dissipation down to where I feel is a comfortable level. And if I still have around 330 volts across the tube, that's only 10% over spec, and I think the tube can handle that. And from my experience, running tubes at high voltages really does sound better. They really seem to, most tubes that I've worked with, audio tubes, seem to like having high voltages run through them. And so I don't think that extra 30 volts is going to be a real deal killer. And I'm okay with running these other rectifier tube. I've got a pair of those. I don't like that they're indirectly heated. And as you saw, the B plus went up over 460 volts for, a short period of time. And that's one reason I always oversize the filtering capacitors, because you want to make sure that they can handle the spike on initial startup and not explode. If I'd put 350 volt caps in here, anticipating the B plus being around 330, these caps would have exploded when we just powered this amp on. So don't want that kind of stuff happening. So I'm going to change out these resistors and see what kind of cathode current we have after I do that. Okay, we've done some adjustments to the amp, and what I'm finding is these transformers really are putting out too much voltage. And I think part of the problem stems from, because they're being used on a monoblock that doesn't have a lot of load on them, that it's making the voltages out of them much higher than I was anticipating. Even things like the heater voltages at 120 volts in, we're getting almost 7 volts on the heaters, which is way too high. So I don't really want to throw away these transformers and have to go buy new ones, which would be probably a couple $100. So what I think I'm going to do is try to buck the input voltage to the amps down to 112 volts. And that's where I've got the Variac set right now. It's got 112 out instead of 120. And if we come in here and check our heater voltage, now we got 6.48, or basically 6.5 volts, which is reasonable. That's within the range of what is acceptable on the tube. It's easily within 10%. So that'll work. And I do want to run this amp hot enough to really make good power. So we come over here and switch to DC. And there's our plate. Got 340 on the plate. I ended up going to a 2K resistor here on the screen, and that gets our voltage on the screen down to 338, which is a couple of volts below the plate. And I've just found over the years of playing with this stuff that keeping the screen voltage slightly below the plate voltage has less distortion, and the amps to me just sound better. So then we come over here and we got 12.35 volts on the cathode. and 12.26, so they're basically very similar. Here we got 340 on the plate, 339 on the screen. Was it 341? So we got a couple of volts drop between the plate and the screen, so both the tubes are running at a good space. I also changed out the 270 ohm cathode resistor for a 330 to lower the current draw through the tubes. I really just don't see a huge advantage to running these things just red hot, especially in a push-pull amp. You're probably not going to gain much, if anything, as far as power, and it just stresses the tubes out. So one thing nice about having this Variac, when we finish this amp up, I'm going to try testing it at everything from like 108 volts in to 120 volts, because it'll handle running at 120 volts. It's just the tubes are running super hot. Like, let me turn it up a little bit here. That's probably, by this knob, is close to 120. And now we have 355 on the plate. And then you end up with 13 volts on the cathode. And that's running the tube at like 93% or something like that. And while it would stand it, I just don't see a reason in doing it. And again, we got the heater voltages are going to be too high. Let me show you what that is real quick. And we got 6.8 volts. And that's probably more like, 118 or so in. I don't want to turn it up too high and pop these tubes. So anyway, I thought about trying a higher voltage drop rectifier tube, like a 5Y3, but then I still got the problem with the heater voltages being too high. So I think the best solution is to set up some sort of a bucking transformer to drop the line voltage going to the pair of these, at least for my uses. Obviously, I wouldn't recommend buying the transformers that I bought. I think these are just too hot for this amp. And I think some of the smaller 600 volt Hammond options probably make more sense, and make sure that the 6.3 volt winding in the transformer isn't rated for too high an amperage where the voltage doesn't get pulled down into the range it needs to be. I mean, I could come in here and, let me turn it off here. And I do like to, before I really poke around inside an amp at all, get an eye on the DC voltage. And you can see with the bleed resistor plus the voltage that gets pulled out by the tubes still running when you turn the power off, we're already down below 12 volts, so the amp's safe. I mean, I could come in here and put another RC network over here on the B plus to drop the voltage down, and then come over here and do another dropping resistor on the 6.3 volts. But then you're putting a bunch of heat inside the amplifier to bleed off the excess voltage, where it would be better to buy the right transformer to start with. And given that I've already got these and I've already built the amp to this point, I think it makes more sense to set up, an 8 to 10 volt reduction on the line in voltage to deal with getting the voltages where we want to see them inside. So anyway, let's wrap up this video. Well, after that testing session, I have to admit I'm pretty disappointed. This is the first time I feel like I've really just blown it ordering parts for a build. Actually, I think it is the first time I've really blown it. I originally bought this iron to do a clone of an ST35, and so I just bought the voltage transformer that they were showing in the Dynaco schematic. And I think what's going on here is the vintage tubes that amp was designed around could actually handle a lot higher voltage than these new production ones can. And it's probably why the new old stock of these tubes are so expensive, is because they can handle higher voltage and current than they're rated for, and a lot of the amps designed in that period took advantage of it, trying to squeak another couple of watts out of the design. And we don't have that, and I'm not really interested in designing an amp that needs $400 worth of new old stock tubes to operate it, or they may even be more than that now. They've gotten ridiculous. And again, I think it's because you have to have those new old stock Mullards and stuff of these EL84s to put in those old amps that were designed. I think Fisher and some other people designed them that running like crazy plate voltages and running at almost 15 watts, which these aren't going to take that. So in the video I talked about maybe just running a bucking transformer to make these things cooperate, and guys, that's just, I can't do that. I just feel like that's a really shady way of trying to fix this problem that was created from ordering the wrong parts. And I don't want to build a project to show you guys, hey, here's how you can build something, kind of a DIY follow along like these other ones I've been doing, and tell you to order parts that I haven't tested and that I don't know whether they really work or not. And so to do this right and to keep doing kind of what Skookie Designs has been doing, I got a couple of Hammond 600 volt power transformers ordered from Mauser, or I think it was DigiKey, and they should be here later in the week. And so I'm going to pull these off. I've also decided, since these holes aren't going to line up, and I don't want to throw this whole chassis away just because I goofed on that one thing, that I'm going to do like I did on another build, and I'm going to take a piece of this copper clad board and cut it the size of this footprint, and then paint this black and put it between the power transformer and the chassis itself. And we can pretend like I'm just trying to shield it from the, the power transformer. So, hey, we can play that off, right? So, I don't know if anybody's, you guys aren't going to buy it, but whoever I end up selling these monoblocks to, I can tell them that. So, anyway, I can cover up these holes that are in the wrong place, and it still come out looking really nice. And actually, this does kind of serve a little purpose, so I don't feel bad about doing that. Anyway, they should be here next week. The other thing, too, is I probably wouldn't feel as bad if the 6.3 voltage wasn't so high, because 7 volts is just way too much. And I don't want to have to put, bleeder or dropping resistors inside the amp that have that much current running through them, because they're going to get super hot. And even though, if I get high enough wattage ones, they'll handle the heat, but you got all that heat. I obviously don't want to put them on top either, because those are kind of ugly. And what caused that was, if I'd actually ordered the EdCore power transformers that have 2 amps on the 6.3 volt instead of 4 amps, I wouldn't have that problem. So that's something we can all learn from this. I didn't think that through when I was buying these, that I needed to match the 6.3 volt amperage to the actual amperage draw that I was going to be using, because if you don't, like in this case, this is a 4 amp 6.3 volt and I only need 2 amps. So it's going to make the voltage a lot higher than it would be if I'd got the 2 amp version. So since so many things are off, I'm going to feel a lot more comfortable just running a 600 volts, can pull the plate voltage down. We can, I may end up going back to the 270 ohm cathode resistor. Don't know yet. But I'm going to get that transformer here, get it all wired up, and I may go ahead and just knock that out off camera, because I don't think you need to see me fixing my mistake. And then we can come back and recheck our voltages. And if all of that looks good, then we can wire up this phase splitter driver tube and get this project finished up. So anyway, $200 mistake on my part. Sure, I can use these power transformers on a future build. Again, I hate that they've got that 4 amp 6.3 volt winding, because that's going to be tough to bleed that off unless I end up finding some, high amperage tubes to use on them. I don't know. Anyway, my problem, not your problem. Again, just hopefully y'all are learning something from my mistakes. Again, they should be here later this week. And again, if you're enjoying this content, please subscribe to the channel. Subs are getting up pretty high, which is good for everybody. It gets this content propagated more, get more people viewing it, get more people watching this content, get more people building my projects. Yay! I love hearing people saying that they've built my stuff and it sounds good. I'm seeing quite a few people on the forums talking about building my budget 300B amp and talking about how great it sounds. So that's really cool. And that's one of the things that inspires me to keep doing this stuff, is that I know people are actually building this stuff that I'm showing y'all how to build. So anyway, subscribe, like the video, and we'll be back when those transformers come in. Hope you'll have a great day.